So to find the vertical asymptote, all I do is I take my denominator and I set it equal to 0 as long as there's not a cancellation with my numerator, right? So I want to make sure, sorry, that I factor both of them and make sure that there's not anything that cancels out, because if it cancels, it's not a vertical asymptote. So just really quick on the top here, I'm just going to factor 2 out and I still get x minus 4. So there's nothing that will cancel out in number 1. So that means my vertical asymptote, I'm going to take that x minus 1 and set it equal to 0. So that means x equals positive 1. And that is my vertical asymptote. And remember, vertical asymptotes are a line, so it needs to be written as x equals 1 because it is the equation of a line. A vertical asymptote is a line. So for the second one, I'm going to do the same thing. I'm going to factor it. So on the top, I'm going to get, what am I going to get on the top? Minus 4 and plus 3. And on the bottom, I'm going to get x plus 2. Nothing cancels. So that means x plus 2 equals 0, or x is going to equal negative 2. And there's the equation of my asymptote. For number 3, definitely nothing's canceling out. So negative x minus 2 equals 0, or x equals negative 2. And then for my last one, I've got 3 times, oops. Let's try this one more time. X minus 1 all over, let's see, x and negative 4 and negative 1. That means these cancel out. So where's my asymptote going to be? Is going to be x minus 4 equals 0, or x equals 4. Okay, is there any questions on those? On how to find the asymptotes? Awesome. Okay. So we're moving on to the second part of rational functions. And our question is, what's the difference between a vertical asymptote and a whole? So we're still looking at vertical asymptotes. Good. Another one of the good reasons why we did this warm-up too is because it kind of blends into with what we're doing today. So it says without using a graphing calculator. So please kind of be honest and don't use one, because I can't see you, so try not to use one. And match each rational function with the correct graph. Write the function below the graph. You may want to match the ones you know first. Consider the exponent rules and how the functions may reduce to a simpler form. So here they are. And if you need to, because you don't have a paper, you could just label the graphs like A, B, C, D, E, F, G, and H, and then the equations 1, 2, 3, 4, 1 through 8, and then line them up that way so you know which ones go with which. So that would work also. So go ahead and match the equations, and I think the easiest way to do this for me would be, I would simplify the equations first, because several of them can be simplified, and then match up the equations that you know, find some vertical asymptotes of the ones that you don't know. Just do whatever. Most of them will be fairly easy once you do. I think you can graph them with all that. If you simplify them and then graph the ones you do know and then find your vertical asymptotes, you should be able to find the functions of all of these, the graphs of all of these functions. Okay, I'll give you a few minutes. Talk through this. So number 1 does not simplify. So what I did is I looked at the asymptote here. So I know it has an asymptote at x equals 2. So that means it either has to be A or F. And here's my asymptote on F. And here's my asymptote on A. So that means 1 is F. Okay? And then number 2, I can't simplify anything, so that means it has an asymptote at x equals 0, so that's my other choice, which would have been A. Okay? And then number 3 simplifies to x, which means it has a slope of 1 and a y-intercept of 0. So it's a line, so it has a slope of 1, a y-intercept of 0. It has to be C, so that's 3. 4, if I simplify it, it equals 1, y equals 1 with, and I'm going to come back to that one in just a second. And then number 5 is going to be, if I simplify it, it's going to equal x squared. And I have an x squared, y equals x squared is function d. So that was b5, and this is d. And then if I look at 6, it simplifies to x minus 2, which means I have a slope of 1 and a y-intercept of negative 2, which means this is E. And then if I look at 7, that means it's 1. We're going to come back to that one also. And if I look at 8, this means that's x minus 2 squared. I have another parabola that is shifted to the right 2, so that's h, so that's 8, and this is h. So now I just need to look at the 2, 7 and 4, because they're both y equals 1. What's the difference between them? And if I look at what's the difference between them, it's this little hole in my graph. One is at 0 and one is at 2. Well, the only way I can see that is at here on number 4. It's undefined, defined at x equals 2, and here it's undefined at x equals 0, so I'm going to assume that this one is 7 and this one is 4. So this would be G and this one would be B. Okay? Any questions? Yep. Okay. So that was kind of my thought process when I was doing those graphs. Okay. So I hope that some of you see that, and that's kind of where we went. So next page at the top, it says which functions have asymptotes and which have holes in their graphs. Describe how the structure of the equation determines whether the function will have an asymptote or a hole. So we're going to actually answer that question coming up as we come along. So we're not going to answer that from the equations above, but I do want you to answer the first part, which equations have asymptotes and which of the functions have holes in their graph. So if you can just write those down, of which of them have asymptotes and which of them have holes, I would greatly appreciate that. Thank you very much. So the ones that have asymptotes, A, S, Y, M, P, are the 1 over x minus 2 and the one that says 1 over x. And the one that had holes was everything else, right? I just put everything else. You guys wrote down letters. I just put everything else. It was everything else. And then I kind of noticed that everything else, something canceled on it, right? Okay, so in everything else, something canceled, and that just happens to be where, if you look, that just happens to be where the hole is. So when I'm factoring my equation or simplifying it, if I simplify it, that's going to be where a hole is in the equation, in my graph. So let's talk about graphing calculators. And I don't even think Desmos. I don't.
have a question about that.
Yes.
So what if there's like 2 numbers on the bottom, but only one of the bottom numbers simplified? Would that be a...
So then I would have both. I would have both asymptote. We're going to talk about that. We are going to talk about that, but that's a good question. I would have both. I would have an asymptote and a hole. So you're saying if I have two factors, like if I have, let me see if I can make something up, Yellow. If I had x minus 3 over x minus 3 times x plus 4, something like this? Is that what you're saying?
Yeah.
And then this one cancels, right? So what would happen is I would have a whole, I'd have a hole at x equals 3 and a vertical asymptote at x equals negative 4. And we're going to talk, that's what this whole lesson's about today. We're going to talk about that right now. Are you okay with that?
Yes.
Okay. I'm going to try and make this bigger now so I can erase this. And of course I can't. Oh, there we go. Okay. So basically, how do I find the holes? Holes appear when there is the same factor in both the numerator and denominator. So basically, I'm going to see what factors did I cross out when simplifying, and then how to find the location, the y value of that hole, because in both your homework and then when we're graphing these, I don't only need to know the x value, I also need to know the y value, because I need to know where on that graph to put my hole. I plug that x value back into my simplified equation. So if you look at, I came up with this graph first and I made an equation to go with it, so it should work. I have this equation, x minus 2 canceled out, so I should have a hole at x equals 2. Okay, so how do I find out my y value? Well, I take that and I plug it into my simplified version, my simplified equation, and I get 2 plus 1 equals 3. So my point for that should be 2, 3. And if you look at your graph, I go over 2 and up 3, and there's where my hole is. And that's exactly what you do when we get to the graphing part and how to demonstrate it on a graph, we'll show you. But you just draw a hole, a circle on your graph, just like that. So that's how we find it. We find the location of it by taking that hole and plugging it back into the simplified equation. Sometimes we get some ugly locations, but that's how it's done. Is there any questions on that? Okay, so let's go ahead and see if we can do it. It's fairly simple, just like yesterday's. It's if we can find a vertical asymptote, we can find a hole. Determine whether the graph of the rational function has vertical asymptote, a hole, which is called a removable discontinuity, neither or both. Wow, let's read that out of order. And then find the vertical asymptote and or holes. So I'm going to find out if they have them, and then I'm going to find them. So on 1, I really can't factor anything, right? Because x squared plus 4 doesn't factor. 4 on the top doesn't factor. So this one, for number 1, it has neither a hole or a vertical asymptote. Right? Because my domain on this one, which we found yesterday, was negative infinity to positive infinity. There's no value for x that I can put in there that will give me a 0 in my denominator. Okay, is there any questions on that one?
Yeah, I have a question.
Okay.
So when you said it can't factor anything, isn't 4 a perfect square?
Yeah, but so remember, I'm gonna okay, let me say this a different way. Sorry, Yellow. So if I was to rewrite this, x squared plus 0x plus 4, right? So if I'm going to use my my graphic organizer, I need to have that term in there. I want two numbers that add to be 0 and multiply to be 4. So give me two numbers that add to be 0 and multiply to be 4. Yellow.
Yeah, there is none.
Yeah, there are none. Because in order to get it to be 0, I need to have one negative and one positive, and therefore it can't multiply to be a positive number, right? It only works if this sign is negative. Does that make sense? If it was x squared minus 4, then it would factor. But if It's, oh my gosh, I can't talk today. But it's x squared plus 4, so therefore it can't factor. Okay? Did that help a little bit?
Yeah.
Okay. All right, so let's talk about the second equation here, part B. So I have an x plus 2 on top, and luckily I don't have to factor. I have an x plus 2 on top and an x plus 2 on the bottom, right? So my new equation is 1 over x, okay? So I have a hole at x equals, not positive 2, wow. X equals negative 2. And then I want to find the location of that hole, right? So how do I find the location of that hole? I plug that negative 2 in there, and the location of my hole is going to be negative 2. Wow, okay. Negative 2, negative 1/2. And then I have a vertical asymptote at where? Where do I have a vertical asymptote at? What's going to make this 0 now? This one 0.
0.
0. And I have a vertical asymptote at 0. Nice yellow. Louis, does that make sense? Why the hole is at negative 2? Sorry, I guess I'm not sure what B that is. Is this B? Yes, functions that have asymptotes have x in the denominator. Yes. Oh, okay. Okay, I was just a little confused. Thank you for clearing that up. Okay, and then if we look at number 3, and I'm going to factor. So I've got x plus 2 over, let's see, what does this factor to? X and negative 5 and positive 3. So nothing cancels, so I have no holes. And vertical asymptotes at x equals 5 and x equals negative 3. All right, so let's go ahead and work through these. And I think most of everyone's in here except for 2 problems I saw that we're going to talk about. So the first one, I'm just going to go ahead and write the answers in except for those 2 that I'm going to work on. So holes, so holes, none. And vertical asymptote, x equals 2 and x equals negative 2. Holes, none. And vertical asymptote, x equals negative 5. Beautiful. Everyone was good on those 2. On this one, we got holes, none. And vertical asymptotes, x equals 5 and x equals negative 3. Good job. Everyone's doing good on those. Let's see. D. Again, the first 4, everyone was good on. Holes, none. Vertical asymptote, x equals negative 2. And then we come to this one. So if I simplify this, I get 1 over x plus 2. Can someone tell me on this one, did I get rid of any x's? I only have a hole if I cross off an x. No, the 5 divided by 5 makes a 1. It doesn't, there's no x value, so there's no holes. I didn't get rid of any x's at all. So there's holes, there's none. No holes. My vertical asymptote would be, I think everyone got the vertical asymptote right. X equals negative 2. It was just the whole part Everyone said, I think everyone either said -5 or 5. I can't remember. There was various answers on that one. But there's no x there, so there will be no hole there. I can get rid of constants all I want and not worry about it. And then the last one here, if I simplify, I'm going to get 1/7, and I do have a hole. I did cancel a variable, so my hole is going to be 0, because x is going to be 0. If I just get rid of x by itself, that means x equals 0. That's because 0 is going to make the denominator 0 on that one. And then it will be 1/7. And my vertical asymptote, none. I don't have any left because I have 1/7. Okay? Questions? Okay, we have 6 more problems. They're a little harder than this one. So go ahead and work on those 6 problems. So everyone can see it one more time. So if I factor h, right, I factor out a -3, and I would get x minus 2. And in my denominator, I will factor out an x, and I'll get x minus 2. Okay, is everyone okay right there? You didn't factor out a negative, right? And then I cancel that out. And my equation becomes, my new equation becomes -3 over x. So I have a hole at x equals +2. I take that 2, I plug it back into my new equation, I get -3/2. And then I do have a vertical asymptote because there's still an x left in my, oh, okay, yeah, the negative. I still have an x left in my denominator, so I have x equals 0. Because there's nothing with it, so just x equals 0. Okay? So let's go ahead and see how you do on the rest of them. Everyone who's not putting out h now, so because it's going to be easier for me to show everyone. Sorry. So if I factor h, I get x over negative x times x plus 2. I cancel out the x's, and I'm going to get -1 over x plus 2. That works. No, sorry, the negative needs to stay in the denominator. Sorry. Oh, I need to fix this. I get 1 over -x minus 2. If I distribute that negative back through there, sorry. And so if I have the x by itself, yellow, it's only an x by itself. What's going to make this 0? Well, my hole is going to be at 0, not 1. 1 doesn't make the denominator 0. Holes and asymptotes are what's going to make the denominator 0. So 1, if x equals 1, that 1's not going to make my denominator 0. What's going to make my denominator 0 for this particular thing that I crossed out is 0. I hope that helps. And so if I substitute 0 in here, I get -1/2. Oh, beautiful. Okay. And then my vertical asymptote is x equals, yeah, I did that right. That's perfectly right. X equals -2. Okay. Oh, that's where my mistake is. Sorry. I made a mistake here. This should be a -2. So that makes this a +2, and that makes these both positives. Okay, I knew there was some mistake in here somewhere. This is a minus, makes this a plus, makes that a plus, and makes that a plus. Okay, there we go. Thanks, Isaac. Okay. Yellow, did that make sense, why it's 0? Okay, awesome. Oh, okay. Okay. Nice job. So you guys, the time is running out, so I'm just going to go ahead and go over these. The last 4 really quick, although the ones that you guys have, looks like most of you guys have got this now. F, I'm going to factor, right? So it becomes x plus 4 times x minus 2. And when I factor out a -4, I get x plus 2. Nothing cancels. So wholes would be none. And my vertical asymptote would be x equals -2. It's the only place that's going to make the denominator 0. Okay? And then J, I'm going to factor again. So I'm going to factor out a -2. And I'm going to get, a -2x. Let's try this again. I'm going to factor out a -2x. And I'm going to write this underneath because I don't have enough room for some reason. Equals a -2x. And I'm going to get x minus 3. And then the denominator, I'm going to factor out, let's see, what does this become? X minus 3 and x minus 4. So the -3's go away. So my equation becomes -2x over x minus 4. Okay, so my whole is at 3. And then to find the y value, I'm going to substitute 3 in there. So I just kind of came down here. I said -2 times 3 divided by 3 minus 4, which was -6 over -1, or 6. Okay, and then my vertical asymptote is going to be x equals 4. Awesome. Any questions so far? And then F, ooh, F is lovely. Okay, so I'm going to factor a -4 out of here first, a -4x. So I'm going to get x squared minus x plus x minus 6. Okay, that's great. Okay, so if I factor this, the top becomes, what does the top become? X plus 4 and x minus 2. Yeah. All over -4x times x plus 3 and x minus 2. So those go away. So my new equation becomes x plus 4 all over -4x times x plus 3. Oof. So I have a whole at 2, and then I need to substitute that in, so I get 2 plus 4 all over -4 times 2 times 2 plus 3, so 6 over -8 times 5, 6 over -40, or 3 over -20. So -3 over 20 should be that. And then I have a vertical asymptote at x equals 0 and x equals -3. Sorry. And then for the last one, we're going to factor, it looks like we're going to factor 2 out of the top. So if I take a 2 out, I get x squared plus x minus 2. So if I factor this, I'm going to get x plus 2 times x minus 1 all over x minus 3 and x minus 1. So those go away. And my simplified equation becomes 2 times x plus 2 all over x minus 3. So I do have a whole at 1. I plugged my 1 in. I get 2 times 1 plus 2 all over 1 minus 3. So 2 times 3 divided by negative 2. So that should be negative 3. And I have a vertical asymptote at x equals positive 3. Okay? Any questions? Any questions? Sorry, I'm losing my voice. Okay, so we have about 6 minutes left in class today. Wow, not a lot. But the delta math is just like this. Finding your asymptotes. Although you don't have to find them both at the same time. I did do a few more questions on finding the vertical asymptote like yesterday or Tuesday. And then most of them is finding the whole. So you do have to find the whole, the x and the y value. So if you're putting an x in there for the whole for some reason, it's not going to accept that. You're going to have to actually put in the value. So like the negative 3 or the negative whatever some of them were, what negative 3/20. You'll have to put in the correct value. Let's see, is there anything else? And I think there's like 11 questions, maybe 12. I don't remember how many there were. So it's 10 to 12 questions for today's homework. Okay. Please